Alright guys, today we are going to be learning how to estimate the value of radicals. Now let me put my computer here really quickly. Don't do this. Okay, how to estimate radicals. Now, estimating radicals is different. Estimating is not the same as simplifying. They're not the same. If you see the instructions that say estimate, do that. If they say simplify, do that. Do not conflate these. These are not the same thing. Estimation is something, as you've learned before, that's going to allow us to say, this is roughly what this radical is equal to. Now, quick review. What is a radical? Well, a radical is an inverse operation. Is the inverse operation of squaring something. Meaning, square root of 9 is equal to 3. 3 squared is equal to 9. You get the idea. Now, if we were to combine these, and I'll do a separate video just really quickly detailing this, if we were to combine this and say, oh, well, what's the square root of 9 squared? Well, that is the same. These inverse operations are going to cancel one another out, and that's just 9. Because the square root of something squared is just going to end up being the radicand itself. But let's get back into this. That's your review of what radicals are. Sometimes it's going to say estimate to the nearest whole number. It's going to want us to estimate to the nearest whole number. And I'm going to show you that, and then sometimes it will also ask the nearest 10. I'll show you that as well. So we'll start off easy. Square root of 24, radical 24. And it says, well, estimate to the nearest whole number. What I have to do at this point in time is this, and I like to use a number line here. You do not have to do this, but you can go for it. I think to myself, well, what are the two perfect squares on either side of this? What are the two perfect squares? Well, I know 25, I know 16. Those are the two perfect squares that are on either side of this. Now, one of the mistakes a lot of people make is they'll say, oh, well, on one side is 25 and on the other side is 9. Well, that's technically true, but they are not consecutive perfect squares, and that's something I really want to stress. We need these to be consecutive perfect squares, meaning, I'll show you. So this would be 16. That means this is 4, and this is 5. So hopefully some of you can see this very quickly. 24 is 1 away from 25. 24 is 8 away from 16. So which is it nearest to? Much closer to 5. It's significantly closer to 5. And if you can't see that, we can look at it this way and say 4, 5. If this is the square root of 16, this is the square root of 25. 24 is going to be right about here. Square root of 24 is going to be right about there. It is significantly closer to 5 than it is 4. Now, sometimes, though, it's going to say, let's actually do one more just to make sure you understand this. To the nearest whole number, let's estimate the value. To the nearest whole number, let's estimate the value of 128. Well, I need to find the two consecutive perfect squares on either side, and I'm going to say 121 and 144. Well, this is 11, and this is 12. So now I said to myself, all right, that's a distance of 7, or a difference, rather, of 7. That is a difference of, I can do that in my head, 16. Okay, so this is going to allow us to see, well, this is significantly closer to 11. 7 is less than 16. Therefore, the nearest whole number is 11. But sometimes it's going to say, what about estimating to the nearest 10th? If we need to estimate to the nearest 10th, this is where it becomes a little bit more guesswork. But I'm going to show you some key steps that are going to help you out. So let's start with radical 32. Well, step 1 I want to do is find 2 consecutive perfect squares on either side. Well, those are going to be 25 and 36. And that's 5 and that's 6. And then I'm going to say, great, what's this? That's the 7, and that is 4. So now what I can say is this. I'm going to estimate that this is about 5.7. Now I'm going to tell you how I did that, and then I'm going to show you some steps that are going to allow you to do the same thing. What we see here is that 7 is greater than 4, not by a significant margin. In fact, if we were to take 1 away from here and add 1 to here, we would have 6 and 5. So it's almost an equal. It's almost halfway, being 5.5, almost. But we have 7 and 4, which means that 32, the radical 32, is somewhat closer to 36 than it is to 25. Again, this is a difference of 7. This is a difference of 4. Now, what that means to me is this, and I'm going to show you this visually. There's also a way to do this algebraically, and one of your extra credit assignments is if you can figure out what that is before I tell the class or group, you can do it. Now, 5 and 6, we've determined this is radical 25, this is radical 36. Well, halfway, I'm going to count 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 36. Now, we had said this was about 31. That's about halfway, so a little bit more on the other side now. When I look at this, I'm going to see that 32 is about here. It's a little bit more than that halfway mark that I had set. The halfway mark is actually technically right there. So it's a little bit more than that. So it's going to be about 5.7, because this would be, I wrote this on the wrong side, I apologize. Radical 32 is what we're concerned with. If this is 5.5 or halfway, then this is going to be about 5.6-ish, 5.7-ish. So it's somewhere in here. If you were to estimate 5.6 or 5.7, both of those would be completely acceptable in this level of math. And again, if you can find the algebraic way to do this, you'll get some extra credit. We will be talking about that whole class this week. So let's try one more. And this time we're going to go with radical, I don't know, 57. Now I need to find the 2 consecutives on either side, and that's obviously going to be 49 and 64. My second step, I'm going to determine the difference here, which is 8, the difference here, which is 7. Now, hopefully you see where this is going. Draw my number line. This is radical 49, which is 7. This is radical 4. I'm going to count this out. 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. Those are not the greatest spacings. I agree with that. I understand. But let's count this out. 49, 50, 51, 52, 53, 54, 55, 56, 57. And as we can see, it's ever so slightly past what would roughly be our midpoint, which is right about here. So I'm going to estimate about 7.6 because it's ever so slightly closer to 64 than it is 49. So once I have that, I'm going to say, well, if this is 7.1, 7.2, 7.3, 7.4, 7.5, these seem to match up nicely.